Happy Wednesday and happy day before Thanksgiving, everyone. This week was one of those weeks where we did a lot of important things and none of them are exciting to make a video about. So this week we are still waiting on our injection molding supplier to finish making the modifications to the sled mold. They're taking a little bit longer than they said they would, but hopefully that's okay. The rest of our parts are waiting for us at our freight forwarder, and we've been working on a major firmware rewrite to clean up and improve the firmware. Roman has actually been working steadily on the firmware in the background for a few weeks now, so I asked him to make a video about what he has been working on.
There's a lot of work that's been going in the past couple of weeks that we haven't talked about in our updates, partly because it's kind of boring, but I'm going to try to explain to you what we've done. We've done a major update in the code for Maslow 4, and most of it is kind of invisible at the first glance, so let me try to explain you what we've done. If you want to do something quick and easy for a prototype or to test something if it works or not, you write a piece of code, like if you need a machine to do something, like we need to do a calibration, for instance, process that takes a whole hour. And it gets to calibration and it goes through all these steps of calibration one by one, and it doesn't do anything while it's doing this piece of code. It can't do anything, it doesn't react to anything that user does. It doesn't check on anything else, it just does this one thing. And in programmers' terms, code like that is called annoying, but also blocking, because it blocks the machine from doing anything else. And this approach is good when you need to do something quickly and to test if it works. But when you get to the more of an end product, you really need to get rid of that, because it's just very unuser-friendly. There's a big difference between a working code and the code that is easy and not annoying to use. So a big part of this update was about that, but also it's just the way the code is supposed to be: expendable, robust, it doesn't interfere with anything else. Another big part of this update is making it safe to use, because for now everything kind of works, but we don't have any precautions in case something goes not according to the plan. And we are trying to find the ways you can break the machine, actually. And we want to make sure this never happens, whatever goes wrong. Like there's a lot of things that can go wrong, like the belt can get detached, or the belt can get stuck on the piece of something, etc. It's a lot of mechanical, since it's a mechanical machine that interacts with the outside world, which is chaotic and unpredictable in its nature. We want to make sure that we account for that.
So we've been working on making all the code non-blocking, working on cleaning up our state transitions, making sure things work the way they should. So for example, if you pause it during the calibration process and then resume it, it'll pick back up right where it left off. We've also been doing a lot of monitoring of things to make sure the machine is working the way we expect it to. Things like if an encoder becomes disconnected, if one of the belts is moving when it shouldn't be or isn't moving when it should be, or if one of the current to one of the motors is too high, or if the tension in one of the belts is too low. Basically, the machine is continually monitoring itself, and if something in the world goes wrong around it, it'll react to it, it'll pause itself, it'll throw an error message and alert you that something's come up. I also realized this week that we've never actually shown the full calibration process, partly because it's not that exciting to look at, but we need things to show this week. So here is what the full calibration process looks like. This is something that you only need to run once when you set up a new set of anchor points, but you have the option to run it at any time that you'd like to. Once you run the calibration process, the coordinates of each of the anchor points will be stored for the next time you want to use it. What's happening here is that the machine is using 2 of its belts to move itself through a grid of points, and at each point it pulls the other 2 belts tight and records the lengths of all 4 belts. When it's done, the machine uses those measurements to mathematically solve for the precise XY coordinates of each of the anchor points. Thanks for sticking with us through a somewhat boring weekly update. Everything we did this week was super important, but none of it was exciting to talk about. I spent an entire day reading insurance policies. I assure you it was very boring. I'm not even going to talk about it. I did learn that we are insured for acts of terrorism, but only from certified terrorists. I'm not sure who certifies terrorists, but anyway, happy Thanksgiving and have a great week, everyone.